Ask about this. Like radicals. Where is the radical part of this? What makes something a like radical? The coefficient or the radicand? The radicand. So in C, we got to get that to somehow look like that. Right? Right? Okay. So we got two. I'm going to use two different colors to make it easier on everybody. Blue one, yellow one. Which is the one that has some math that I can do to change how it looks? Montage. The yellow one can be changed, right? The blue one cannot be changed. Why? RJ. Right, there's no fourth roots under there. It's as simple as it's going to get, yeah? So I got to work with the yellow one. Well, the yellow one is 81W10 fourth root. So I break it down. 9 and 9, 3, 3, 3, 3. W10 is W4, W4, W2. Is there a fourth root? So what comes out? 3. Is there a fourth root? So what comes out? W. Is there a fourth root? So what comes out? W. Do we write 3WW? What do we write? 3W squared. Fourth root, what did I leave under there? W squared. And I already had W squared. That's what you do. And then I wanted, that's all I had to do is write them that way. Explain your strategy. What did you do? I simplified the one that couldn't be simplified, or that could be simplified. That should be your strategy. That should be the first word of every time you ask yourself ever, what do I need to do here? This looks like a complicated question. What do I need to do here? What should be your first word? Simplify. Why does it look complicated? Because it has not been simplified. Because simplified means make it simple. So when faced with a gigantic problem, the size of the Empire State Building, what should you do? Simplify. Right? If you got to get to the Empire State Building, do you climb up the side like Spider-Man? No, you walk in the front door and push the button that gets you in the elevator to take you up there. Do things simply. How will I get 1,400 feet in the air? Could I fly? No. Should I call a helicopter? No. You should do the simplest thing possible, which is take an elevator. So what should you do here? Do the thing you know what to do, which is simplify radicals. Right? Aye. What's next? Do I need to do D? I don't think I do. Because they're all the same, yeah? All right, what's next? Because 9D. I know, that's what Canadians, that's how my British friends always make fun of Canadians. Because what do you call this? Yes, you all, because you are Canadian, call it a water bottle. You do not say bottle, nor do I, because I am Canadian. We say bottle. We say battery, B-A-D-D-E-R-Y. We say water with a D. Now and then everybody will start going, water. I do not. I say it with a T. Yeah, because you're thinking about it now. Right? Just like you all, none of us say the word physics properly. We say phys-sucks, S-U-C-K-S. Physics. It's not. It's physics. Unless you are French, because then you're used to saying physique, and then you say physics properly, because it's I-C-S. I know, right? Yes. No, you're not saying it wrong. You're saying it the way a Canadian would say it. Someone who has learned English here. What? Yeah, well, no, not physiques, but physics. X with an I-X sound, not U-X. We say physics. Even though you think you're not saying it. To a linguist, you are saying physics. P-H-Y-S-U-X. It does. From on a phonemiological level. Phonemological. Phonemes are the smallest unit of sound in a language. They're not syllables, they're units of sound. So, phonemological is stuff dealing with phonemes. See how much stuff you know, or could know, if you just listened to me instead of talking in the back corner like them? I know, they have no idea what I'm talking about. And I have actually given you more knowledge in that last 30 seconds than you're going to get all day from me in math, because this is review. Crazy, hey? All right, so we're going to do 9D, right? So let's do 9D. 2 over 3 cube root 81. That is ugly because of the fraction, but it isn't, because what is it really? What is the cube root of 81 really over? What is the denominator under the cube? 1. So what I have there is that, yes? So what I really have there is 2 cube root 81 over 3. Right? And then the rest of them. So let's simplify, because that's what we do. I don't know what to do with this question. It looks difficult. So we simplify everywhere we can. That is the first simplification. Don't tell me that isn't easier to read than this, because you know it is. Then what are you going to do with that? Jordy?
Can you take the 3 and multiply it to itself? Take the 3.
This 3? You want to do this to cancel the 3's? I'm not sure what you're telling me to do here.
Yeah.
You want to do that?
Yeah.
Okay. So if you do that, then you got to multiply all of these by 3. So again, what is this unit? What are we doing right now? We're working with radicals. Do you see a radical there? Is it simplifiable? So why didn't 30 of you just go, simplify the radical, you idiot? Except for the idiot part. I mean, I can take it. I don't really care. Right? But simplify the radical. What is it? He waited patiently. Still waiting. It is 6 cube root 3 over 3. Now what are you going to do? To get what? 2 cube root 3. Right? Okay, so, wow, all right, we're in good shape. 2 cube root 3. Some of you are saying, how did this become 6? Well, 81 is 3 to the 4th, right? So I brought out a 3. 3 times 2 is 6. So there's our first one, out of the way. What about this one? Simplify. That's 125 times 3, right? So what's coming out? What's coming out? Harry. Yeah, sometimes that happens. I don't have any control over YouTube. Sure. What? 5 comes out. What stayed in? Root 3. So I got 5 cube root 3 over 4. Right? What's 99? What are we doing with 99? What's coming out? 3. So it's minus 12 root 11, yeah? Plus 5 root 11. Now, where is there some simplifying to be done? Looks pretty good to me. 2 cube root 3 plus 5 cube root 3 over 4 minus 7 root 11. Right? Now, where else is there simplifying to do? Where's a hint here? Cube root 3, cube root 3. They can go together somehow, can't they? Yeah. But aren't they fractions? They are, aren't they? Can we add fractions that look like this? Not when they look like this. What do I need? What do you need to add two fractions? What do you need to add? Yes, Jordy. You need a common denominator. What is it? 4. Is that guy already 4? So is this guy changing? Is this guy 4? What is he? 1. How do you make him 4? By putting a little line there. How do you make him 4? Multiply the top guy by 4. How do you make that guy multiply by 4? Put a little line there. And now it's 8. Right? There's a thing that math teachers all circle or all send around when it happened. 3, 7. And the question is find x. And some kid somewhere once circled it. There it is. And everybody sends that around as math teachers saying how brilliant that kid was for circling that and saying that. I am not in that camp. I think that kid's an idiot. But that's just me. So, what are we doing now? I got 8 and I got 5. So what do I got?
Wait, so we don't change anything in the math?
No, I got 13 root 3 over 4 minus 7 root 11. Now, I don't know what the answer has. It might have 13 fourths. I got to look upside down now like an old man. That was 9D. It does have 13 fourths. Because for some reason, the people that write textbooks think that is better than that. I don't know why. I prefer this one. Would I mark you poorly if you left it like this? No. I don't know why they leave it like this. If they get to here and turn it to here, I don't know why they don't turn it to 4 1/4 cube root 3, quite frankly, because that's what that is, right? But for some strange reason, this, no good. This, perfect. This, no good. I don't write textbooks. If I did, they'd be different. Okay? Okay. Anything else from the first assignment? So either 14, 15, or 19? Going once? 19? Well, because that will take a long time, and I still want to teach a lesson today because it's Thursday. I don't want to waste this whole day doing old stuff. But I don't mind wasting, well, it's not a waste. I don't mind making sure you're all ready to go on. All right. So, speed of a tsunami is related to the depth. The speed equals the square root of 10 times the depth. A tsunami has a depth of 12 meters. Where does that 12 go? Where the D is. So I want the speed of root 10 times 12, right? Right? So that's the root of 120. In math class, what do I do with that? I simplify it to what? I would use 10 and 12, then what? 4 and 3, 2 and 5. And I would stop there. Why? 4's got a square root, yeah? Any other pairs? So it's going to be 2 root 30, yes? That is your math class answer. And it is what we call an exact answer. Is it a real life answer? Would you ever look at a speed limit sign on the highway and have it be the maximum is the square root of 1,600 kmh? No, because what is it? That's actually, what is it? It's 40, right? That's not a real life answer. So this is not a real life answer. You can't say to people on the beach, get out of the way, there's a tsunami coming and it's moving at 2 root 30 kilometers per second or hour or whatever it is. Right? That's stupid. So sometimes, and when I say sometimes, I mean all the time except in math class, you're going to use my most hated thing, decimals. And you're actually going to use a calculator to get this so you have an idea of a real life answer. And of course, the real life answer is going to be slightly more than 10, isn't it? Or almost 11, right? Because what's the square root of 121? And I have 120. So this tsunami is moving at almost 11 meters per second, which is damn fast. 11 meters per second is, of course, almost 40 kilometers an hour. Yes. Tough to get off the beach. Unless, of course, you recognize that, oh man, all the water's gone from the beach. What's happening? No. If the water leaves the beach, run. Where? Away from the beach. Do not run down to the ocean and wonder where all the water's going. Run away from the beach. And don't think about it. Don't be like, I wonder if it's a tsunami. All the water's gone from the beach. No. Run. Don't get your beach umbrella. Don't grab your chair. Don't get your favorite surfboard. Get your kids, your family, your dog, and get out of there. Okay? Another thing you have learned from me today. Already, you've learned the word phoneme. You've learned nobody that speaks English in North America speaks it properly. And you now know how to get out of a tsunami. All this, and you're learning math. Could there be a better way to spend 80 minutes? No, I don't think there is. I've heard what you people do with your 48 times 60 minutes over the weekend. I bought some shoes. I kept up my kill streak on Fortnite. Right? Okay, so don't give me any of that crap. All right, 15. Do I have to do 15? Good. Do I have to do 19? Okay, who's right? Brady says that our friend Kristen is not done. Is Kristen done? No, of course not, because that's the square root. Is there a square root of 4? What is it? 2. Is there a square root that can come out of y cubed? Of course there is. What is it? Y. What was already out there? So what's the answer? Root what? Root y. Yeah, you go. All right, anything with 53? Going once? Going twice? 6D. Oh, 6D is badass. Okay. What are you going to do there? Simplify. What's 135 automatically divide by? 5. 5 goes into 13 twice. 5 goes into 35 7 times. Now what? 9 and 3. Do I stop there? Why? 9's got a perfect square. So what's coming out? 3. What's already out there? So I got 3 times 3. M to the 5. What's coming out? M squared. What's staying in? M. So I got 15M. Yes? What's 3 times 3 times M squared? 9M squared root 15M. What's happening down here? What's coming out? M. What stayed under there? 21. M. Excuse me, I have to sneeze. There it was. What? You look at the light so the sneeze comes. I got to do both? Okay. Simplify. What's disappearing? 1M there, 1M there, yes? What else? Can you get rid of this m now? Okay, this was the answer I just got. Yeah, no. If you are unsure of a thing you are going to do, should you do it? No. But there is something you can do here for sure, yes? Because you now have a single radical in the denominator, right? Yeah. So you could rationalize. Right? Everyone agree? So now my new denominator is just 21m. Because 21m times 21m is 21m, right? And up on top, I got 9m root. Now this is where you've got to think. If you have been just listening to steps because you're busy TikToking or whatever it is you're doing, instead of paying attention to math, you will do 15 times 21. And you will get a giant answer. And then you will have to simplify it. That would be silly. Because what is the first step of simplifying giant numbers? Breaking them into factors, right? Well, isn't 15 times 21 the first breakdown of the factors? Yeah. Right. And then m squared, yes? Yeah. Okay, well right away you see m's coming out, yeah? So now I'm back to 9m squared outside, and I got 15 times 21. What's 15 break down into? 3 and 5. What's 21 break down into? 3 and 7. You see a pair? What's coming out? So I got 27m squared root. What stayed in there? 35 over 21m. What's going there? One of those m's from the bottom, and how many m's from the top? One. And what's happening with 27 and 21? To what? What goes into both of them? 3. So I'm going to end up with 9m root 35 over 7. Now, we know that the textbook likes 9/7 m root 35, but the m might be there. I don't know. What did they do? Oh, now there they left it. Because that makes sense, right? On the very page's answers before, they didn't leave it this way. No. I copied them out of the back of the same textbook that I copied the first ones out of. Because why would I go to all the trouble of making my own questions when some other clown made a whole book of questions? Right? Don't reinvent the wheel. That's the next thing you people need to learn. If someone tells you to do something and somebody else has already done it, use theirs. Yes. Because in the real world, outside of academics, it works. What's next? Now that I've just said that, of course, you're all going to be like, Mr. Myers said we can plagiarize, because that's all you heard. Right? That's all you took out of that whole thing. Yes, it is. Huh?
Control C, Control V.
All right. So we should be good now, yeah? Okay, that was 9. Anything else? Really? Everyone was cool with that and that? That seems like a bit of a lie. $20 cube root 6t over 5. What does that cube root over everything mean? Everything is cube rooted. So I've got 20 cube root 6t over cube root 5. What do we not like there? I don't like the radical in the bottom. So again, if you've been paying attention to just steps, you're going to multiply that, aren't you? And you're going to tell me that cube root 5 times cube root 5 is 5, right? I bet a bunch of you did. Is it? No, because cube root 5 times cube root 5 is cube root 5 squared. There is no group of 3 there. So this needs to be squared. Now, I know I showed you that already, and I probably didn't fool a lot of people, but some of you probably weren't paying attention and didn't do that. So now I have the cube root of 5 cubed, because 5 times 5 squared is 5 cubed. So now I have 5 on the bottom. Up top, I have 20 cube root 6t times 5 squared, which is 25, right? So I get 20 cube root 150 t. Can I break 150 down? In a cube root situation, it's 25 times 6, right? Right? So it's 5 times 5 times 2 times 3. Any cubes? No. Okay, so nothing's coming out of here, but what's happening with 20 and 5? 4 cube root 150t. Yeah? Yeah. Sure. You betcha. Anything else? Going once? Jordy. Do what? 8C. So. Woo. Negative 2 over 3, double root 5 over 12u. So how do we rewrite that? Negative 2 root 5 over 3 root 12u. Where's the simplifying? 12 is 4 times 3, right? So what's coming out? Negative 2 root 5 over 6 root 3u. What are we doing right there? Simplified. A negative root 5 over 3 root 3u. Now what do we have that we don't like? Irrational denominator. So I multiply by 3u root 3u to get 3u on the bottom and what up top? Oh, sorry. 3 times 3u. So it's 9u. 9u. And what do we got up top? Negative root 5 times 3u. 15u. Does that simplify? 15 simplifies? No. No. 3 times 5. No pairs. And that was 8c. Let's see how they wrote it. Was it a fraction? They left it as a fraction because it doesn't simplify. Yeah, yeah? Yeah, yeah, yeah. So are we all good? Yes. All right. Now that your brains are appropriately melted, let us go back to something that's actually pretty easy. Okay? Turn over onto page blah, 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 55. And you get to use your favorite thing, your calculator. I am encouraging you to use it right now. Now everybody's like, yay, thank goodness. I don't have to think anymore. My calculator will do all the work for me for 30 seconds. How do I punch that into a calculator? What's the base? 9. Then you hit your exponent button. Don't ask me what your exponent button is. You need to know it's your calculator. I'm going to use that symbol because that's what you use in programming. A caret, it is called. C-A-R-E-T. Learn it, live it, love it. See, another thing you learned today. And how do you get that? Well, that's bracket 1 divided by 2. Some people will use 0.5. That's fine. But when you get to 3, you don't want to go 0.33333333. Just put the brackets, 1 divided by 2. Then hit equals and tell me what the answer is. 3. Do the same thing with 27. Tell me what the answer is. So it's going to be 27 exponent bracket 1 divided by 3, close brackets. 3. Do the same thing with 625. 625 exponent button bracket 1 divided by 4. What is it? 5. Now, you're intelligent young people. Is there any other relationship between 9 and 3 that deals with exponents? What is the relationship between 9 and 3 that would use an exponent? 3 squared. So 3 squared equals 9, yes? Automatically, that means the square root of 9, I should have done this better, 3 equals the square root of 9, yes? Is there a relationship between 3 and 27 and an exponent? 3 cubed equals 27, which automatically means 3 equals the cube root of 27, yes?
Yes.
Is there a relationship between 625 and 5?
Yes.
What is it? 5 to the fourth equals 625. So that means the fourth root of 625 equals 5, yes?
Yes.
All right. If the square root of 9 equals 3 and 9 to the 1/2 equals 3, what do we know about the square root of 9 and 9 to the 1/2? If this equals 3 and this equals 3, then what do we know about both of them? They are the same thing. It allows us to write this. 9 to the 1/2 equals the square root of 9. Right? Now, look at the radical there. Are there some numbers missing? Are there any numbers in the radical, over here where my little pink circle is, that are not written there?
1.
9 is to the first power, yes?
Yes.
What else is not written there? The index, which is what? 2. Now, use your above average powers of deduction and tell me how to relate this to this. The 1 is the numerator, the 2 is the denominator, the radicand is the base. Right? So, if I wrote it this way, x root y to the a is what? Y to the a over x. That's it. When? When is this true? Always. Let's go. Right? Now there is a small little trick here. The a can live in two places. You can write this as x root y all to the a power, or you can write it as x root y and have the a under there. They are the same thing. Okay? Sometimes it behooves you to do the blue version. Sometimes it behooves you to do the green version. It makes it a good idea. All right? Everybody cool? Now you will notice that something happened to the printing here. It happened in your books as well. So I'm going to go over here. I'm going to write out A. Now A is the hardest one we are going to do on this page because it uses decimals and fractions. So it creeps us out. But, as always, if you can get rid of a decimal in my math class, what should you do? Get rid of that decimal. 0.04 is what in my room? 4 over 100. So that's the base. To what exponent? 3 over 2. Now, what do you know about the denominator of a rational exponent? He waited patiently for everyone to look at the red writing on the right side of the screen that he just told them about. Jordy. No. He waited for everyone to look at the red writing on the right side of the screen. Where did the denominator go in the red writing on the right-hand side of the screen? It went to the index. Is that a denominator? Yes, so it goes to the index. Where did the base go? Because we're all about the base. Nothing? Nothing? Thank you, Tamana. I thought it was funny too. it becomes the radicand, because we're going to use math words, right? So what's going here? 4 over 100. Where did the numerator go? To the power. Now, since this has a square root, we are going to do the blue version, and we're going to put the 3 out here. What is the square root of 4 over 100? 2 over 10 cubed. What is that? 8 over 1,000. And now you're done. Of course, you all want to write 0.008, which I, of course, would let you do, as provided you showed me some work and didn't just punch it into your calculator. Yeah? Yeah. Now, here's what I'm going to do. I'm going to do B right here. I'm going to do C somewhere over here because of the misprinting, right? Yeah. So let's look at B. 27 to the 4/3. How do I simplify that without a calculator? Jordy.
So you write the 3 as the index.
The 3 as the index.
And then 27 as the radicand.
27 as the radicand. Now, I have to stop and think. Does that have a cube root? Yeah, it does. So I can go ahead and put my numerator out here. But let's say you don't know that has a cube root. Right? Then you would put the 4 under there and then break this down. Everybody with me? What is the cube root of 27? 3 to what power? What is 3 to the 4th? 81, and we're done. Everybody got it? Okay, now we have to start getting snaky. What's weird about C? The fraction's on the inside, and there's an exponent on the outside. Have we done exponent laws? If this was not a fraction, what would you do with 2 and that exponent? And then do what math operation? Multiplication, yes? So what are we going to do here? Multiply. What is 1/3 times 2? 2/3. That often fools people. Now, does this look like this? So can we apply our knowledge? What do I do with the 3? Index. What do I do with the base? Radicand. What do I do with the numerator? Power. What is the cube root of 8? 2 squared. 4. Dun, dun, dun. Everybody do D. And do it the way you would do it in my math class. So I'll just go 0.49, exponent button 1 divided by 2, right, Mr. Myers? No, because this is math class where we do math. I'm going to take a pleasant sip of my coffee. My wife made the coffee this morning. It's not the same as I make it. And I've yet to decide if it's better or not. I'm a little bit worried. I'm going to reserve judgment until I get to the bottom of my cup of coffee and decide if indeed my wife brews a better cup of coffee than me. If she does, I will, of course, have to do some research on what she has done. Scroll up? But you have written all those notes down, Jewel.
I missed something.
Oh, heartbreaking. Hint, hint. Does D look like A? So what should you do? Exact same thing, because math is our friend. And math doesn't stab you in the back and change all the rules just because you forgot to text it before you went to see the movie. Huh? You're only doing D right now. You go ahead and do E and F if you wish, RJ. That's fine. Yeah, you do. Yeah, you do. Of course you can. And of course you're all done, yes?
Armand said I did it wrong, and showed me I did it wrong. And I still showed it.
All right.
Still, I'll just prove Armand.
It's 2019. Why would you think that was an issue? What are you trying to say? Uh-huh. But why did you say it all defensively? Did you think I was judging you? You shouldn't think I was judging you because I couldn't care less. I don't understand why anybody cares who people choose to spend their time with. But some people do. I don't know why. Okay. Now, RJ has told me a lie. And it's hurtful. He has told me that he does not know how to do E. That is a lie. Because what part of E makes me want to lose my breakfast? That decimal. So what should I do with that decimal? Turn it into a fraction, which is 3/2. 1 1/2. You do know that because you've been through grade 6. And you know that 1.5 is 3/2. Now, that of course is the square root of what? 16 to what power? Third. What is the square root of 16? To the third, which is 64. So RJ, now that you know what to do with that decimal exponent, you're going to do F. Well, not you. Everybody's going to do F. Ooh, a Panther Planner reminder. Tomorrow there's no school.
No, I did not know that.
Thank goodness the Panther is telling me. Fortunately, it tells me virtually and doesn't creep up behind me, pounce on my back, and whisper into my ear, no school tomorrow, as it chews out my throat.
That's the 22nd century.
Because that is what, of course, a panther would do. It would not remind you there was no school tomorrow. It would eat you. That's true. There would be no school tomorrow for you. 81 to what power? 3/4. Where does the 4 go? What is the 4th root of 81? Because we just did it in B right above. No. 3 cubed, which is 27. Now, listen to me. What have you noticed about A, B, C, D, E, and F? They have all had perfect roots, yes? They all worked perfectly. If you punch them into a calculator, you would get a rational number every time, yes? Would you get a rational number from A? No, why not? Because B cannot possibly have, or 8 cannot possibly have a 5th root, can it? What's the biggest root you can get out of 8? 3, because it's squared, or it's 2 cubed, right? So now we are at the situation that we had when we were talking about the speed of the tsunami, right? That tsunami is moving 8 to the 2/5, which is what you would all say, but it's really 8 to the 2/5. 8 to the 2/5 meters per second. We better get out of here. No, we got lots of time. Because nobody knows what 8 to the 2/5 is. In reality, you would punch this into your calculator and get a crazy decimal, yes? But we're not in reality. Where are we? Math class. So this is what we have, right? Now, if you do the blue version of what I wrote up above, which is this, I'll write it blue, like I had up above. If you do the 5th root of 8 squared, you're screwed, aren't you? Because 8 does not have a fifth root. That's as far as you could take it. Agreed? But fortunately for you, your favorite math teacher reminded you that that 2 could also go down there, couldn't it? Yeah. So that is the fifth root of 8 squared. Now, what indeed is 8 squared? Does 64 have a fifth root? Yes, indeed it does. Because 64 is 2 to the 6th if you broke it all the way down. Can you get a fifth root out of there? Yes. What is it? 2 fifth root. What did I leave under there? 2. And there is your math class answer. Everybody cool? Now, B is idiotic, right? Would you ever have a fraction to a fraction in reality? No. Of course not. We would obviously use the decimal place. So why have I done this to you?
Torture?
No, simply to show you that it continues to work all the time. This is that one question that I will do every so often that has no real anchor in real life, but reminds you that math principles move forward. Yes? So what is this really? 6/10 to 15/7. Yes? Everyone agrees? Okay. So that is the 7th root. Was that a knock?
I don't know.
Who's there? Oh, okay. 6/10. Now, can the 15 be out here? No, because 6/10 doesn't have a 7th root. So we're going to have the 7th root of 6 to the 15th, yes? Over the 7th root of 10 to the 15th, yes? How many 6s can I get out of there? 2. So I got 6 squared, which is what? 36. 7th root, what did I leave under there? 6. Over, how many 10s can I get out of there? 2. 100, 7th root 10. Agreed? Yes. 36 over 100 simplifies to what? 9/25. Absolutely right, class. Well done. 7. And then I got 7th root of 6 over 7th root of 10. And there I am willing to let you stop because this is not real life, yeah? This is crazy talk. But of course, we could simplify this and get rid of that radical by multiplying by the 7th root of 10 to what power? The 6th. And then we could carry on, right? But that would give us 6 times 10 to the 6th. Then we'd have to break that down, take out 7s, right? It gets crazy. Everybody understand? All right. So, you're going to skip 56. That's a stupid page. I used to do it. No, I just realized over the years I don't like doing it. It's dumb. So, your homework for the weekend. Page 57. Page 57. That's it. Now, please look. On page 59, I begin a whole bunch of exponent and radical stuff. Right? That is warm-up. And then I give you a couple of textbook pages. That is warm-up for the review. The review is the assignment. You will do that. We will mark it before your test. Your test will occur next week. So this weekend, you are to work on page 57. And if you wish, which none of you will, if you wish, you could try the textbook pages 62 and 63, which have answers. Okay? Do not, bother with 59 and 60. We'll do that in class on Monday. Okay? Everybody good? Everybody understands? Aye. And you've got 17 minutes right now with which to work. So immediately close your books and start talking to each other about your plans for the weekend, and then tell me on Monday you didn't have enough time to do the homework. Because that's how teenagers work. I know I'm not wrong.